So, not too long ago, the science world got rocked by some pretty wild news. Some people are even calling it one of the biggest discoveries of our time. NASA scientists say they may have found the strongest evidence yet for ancient life on Mars. And here's the wild part. They say the evidence doesn't fit with any non-biological process we know of. In other words, rocks don't normally do this on their own. So what does that actually mean? Did we just find proof that we're not alone in the universe? Or is this another case of don't get too excited yet? Let's break it down. To understand this whole thing, we need to start with the location, Jezero Crater. On July 30th, 2020, NASA launched the Perseverance rover. After cruising through space for about 7 months, Perseverance touched down safely on February 18th, 2021. And it didn't just land anywhere, it landed inside a very carefully chosen site, Jezero Crater. This wasn't a random pick. Geologically speaking, Jezero is a superstar. Today it just looks like a dry, dusty pit. But if you rewind the clock about 3.5 billion years, Jezero wasn't empty at all. It was full of water. Not just a puddle, a huge lake fed by rivers that carved valleys into the Martian landscape. On the western side of the crater lies one of the clearest pieces of evidence, a river delta. And if you look at its branching, fan-like shape, it looks almost identical to river deltas here on Earth. Think about the Mississippi Delta, or even smaller ones near Lake Mead. The resemblance is striking. And that's important because deltas are basically natural storage units for the past. When rivers slow down as they enter a lake, they drop all the sediments they're carrying. Those sediments can trap and preserve things, sometimes even microbes, locking them away for billions of years like a cosmic time capsule. That's exactly why NASA picked Jezero as the landing site. On Earth, if you're looking for signs of ancient life, lakebeds and deltas are among the best places to search. If Mars ever had microbes, Jezero is one of the most promising spots to find their fingerprints. And Perseverance was designed with this exact goal in mind. It's basically a science lab on wheels, complete with drills that can pull out cylindrical rock cores. Think of these cores like Martian history books. Each layer of rock preserves details about the planet's past, its chemistry, its environment, maybe even its biology. Since its landing, Perseverance has collected more than 30 of these samples. Each one is carefully sealed, labeled, and stored. The long-term plan is to bring them back to Earth with a future mission, so scientists can analyze them with the full power of Earth-based labs. But here's the thing. Even with the rover's own instruments, scientists can already learn quite a lot. And among all the samples Perseverance has collected so far, one stands out above the rest. They nicknamed it Sapphire Canyon. So, what's the deal with Sapphire Canyon? This particular core was collected in July 2024. It came from a mudstone formation just beyond the edge of Jezero's ancient river delta in a region named after Bright Angel Falls in the United States. At first glance, it doesn't look impressive at all. Seriously, if you saw it, you'd probably think, that's it? Just a gray rock with a drill hole. Nothing flashy, nothing you'd expect to make headlines. But appearances can be deceiving, because once scientists analyzed it, they realized this little gray rock might hold one of the most exciting clues we've ever seen about life on Mars. Inside the Sapphire Canyon core, scientists noticed some pretty unusual textures. Tucked inside tiny olivine minerals, they found microscopic nodules, we're talking smaller than a millimeter, and odd little boundaries called reaction fronts, places where chemical changes had spread unevenly through the rock. To the untrained eye, it just looks like speckled stone. Nothing special, but when the team hit it with spectroscopy, boom, something amazing popped up: aromatic carbon compounds. Now, organic doesn't always mean alive. In chemistry, organic just means built around carbon. But here on Earth, aromatic carbon compounds are often linked to living or once living systems. And this was just the beginning of the surprises. Next, the chemical makeup of the rock hinted at something called redox reactions. Remember high school chemistry? Oxidation is when an element loses electrons. Reduction is when another one gains them. Why should we care? Because microbes on Earth love this trick. Some bacteria literally breathe iron or sulfur instead of oxygen, shuttling electrons back and forth to get energy. It's one of the oldest and simplest ways life interacts with its environment. So finding signs of redox-driven chemistry in a Martian rock strongly suggests something similar might have been happening billions of years ago. Not proof of life, but a giant neon arrow pointing in that direction. But wait, there's more. The sample was also rich in Vivianite, a hydrated iron phosphate mineral, along with iron sulfides. Why is that exciting? Because here on Earth, Vivianite usually forms in places where you've got decaying organic matter. Think of lake sediments where organisms once lived and then slowly broke down after death. When you see Vivianite hanging out with sulfides and organics, it's not the kind of combo you'd expect from random, lifeless chemistry. And here's maybe the most jaw-dropping detail. It's not just what was there, it's how it was arranged. The organic compounds, the Vivianite, the sulfides, they weren't randomly scattered through the rock. They were all clustered together in the exact same microscopic spots. On Earth, this is a dead giveaway. That kind of clustering is exactly what happens when microbial communities interact with sediments. As microbes live, grow, and die, they mess with the chemistry around them. Over time, that leaves behind distinctive mineral fingerprints, locked into the rock forever. Geologists even have a name for this process, diagenesis. Basically, sediments slowly turning into stone while biology leaves its graffiti behind. Put all of this together, and it's hard not to get excited. We're not just talking about random carbon traces. We're talking about organic compounds, mineral chemistry shaped by redox reactions, Vivianite linked to decaying matter, and all of it clustered in the same tiny regions. Here on Earth, that's exactly the chemical fingerprint you'd expect if microbes had once been there. That's why the scientists cautiously use the word biosignature, a chemical clue that could point to ancient life on Mars. When the results came out in Nature, one of the most prestigious science journals in the world, it's no surprise the story blew up across global headlines. But hold on, does that mean we can finally say, yes, life once existed on Mars? Not quite. This is where things get tricky. Here's the thing about science: extraordinary claims require extraordinary evidence. You don't just declare we found life and call it a day. Instead, scientists start with something called the Null Hypothesis. That means, assume what you found is not evidence of life. Then try as hard as possible to prove yourself wrong. Think of it this way: you've probably heard wild claims about superfoods or crystals curing cancer. Science doesn't take those at face value. The starting assumption, the Null Hypothesis, is that they don't work. Then careful experiments are run to see if that assumption can be overturned. That's exactly what scientists did here. They asked, could regular geology or chemistry explain these patterns? Could volcanic activity, heat, pressure, or random chemical reactions cluster organics, Vivianite, and sulfides like this? They went down the list of every possible non-biological process we know, using both Martian geology and the rover's instruments. And here's the kicker: none of them match the observations as well as biology did. But here's the catch: best explanation isn't the same as proof. There's always a chance Mars has chemical or geological processes we haven't discovered yet, ones that could mimic biology's fingerprints. Remember, our knowledge of Martian geology is still just scratching the surface. And while Perseverance's instruments are powerful, they can't match the full arsenal of Earth-based labs. To be absolutely sure, we'd need to study these samples here on Earth. That's the dream behind NASA's Mars Sample Return mission. Perseverance is already collecting and sealing samples, waiting for a future spacecraft to bring them back to Earth. If that mission succeeds, scientists will be able to analyze these rocks with incredible precision, looking at isotopes, microstructures, and textures in ways that could finally confirm whether life was involved. The problem? The mission's future is shaky. Right now, it's facing serious budget cuts in Congress. Without proper funding, those priceless samples might sit on Mars for decades before we get to study them. On the one hand, this could be one of the most important scientific discoveries of the century, a potential biosignature on another planet. On the other hand, the evidence isn't yet strong enough to say life definitely existed on Mars. What we've got is the strongest hint so far, not proof, but a hint that Mars may once have hosted microbes. History gives us a warning here. Back in the 1800s, an Italian astronomer, Giovanni Schiaparelli, saw thin lines on Mars through his telescope. He called them canali, meaning channels. But when the word got mistranslated into English as canals, newspapers went nuts with the idea that Martians had built massive irrigation systems. We now know those canals were just optical illusions. But the media hype was off the charts. The lesson? We have to be careful. Science advances by weighing the evidence slowly and carefully, not by jumping to conclusions. Even though this isn't final proof, it's a huge step forward. Over the years, we've collected evidence of ancient river valleys, minerals formed in water, methane in the Martian atmosphere, and now, chemical fingerprints that look suspiciously like signs of life. Piece by piece, the puzzle is coming together. And while we can't yet say with certainty that Mars once hosted life, the case is stronger now than ever before. So, did NASA just find life on Mars? Not exactly. What they found is the strongest evidence so far, evidence that points toward biology, though it could still have other explanations. To turn this maybe into a definite yes, we'll need those samples back on Earth. Whether that happens depends not just on science, but also on politics and funding. But one thing is for sure, we're closer than ever. And if we stay patient, cautious, and evidence-driven, we might finally answer one of humanity's oldest questions. Are we alone? If you enjoyed this, don't forget to like and subscribe. It really helps this new channel grow. We've got plenty more exciting science stories coming your way.